Hello everyone, welcome to this talk on DynamoDB. So this talk is aimed at people who are coming from SQL development background. So basically people who have worked with the relational databases like MySQL, PostgreSQL, Oracle, or MS SQL Server. So throughout this entire session, I'll be drawing parallels with the relational technology, and hence it is important to have some kind of relational background. A little bit about me. My name is Anurag. I co-organize the AWS user group Pune in India. I am a cloud and database lead working for a startup called as IQ Innovation Hub. So the agenda of today's talk. So we will cover a little bit small basics of DynamoDB. Then we will look into some of the terms and nomenclatures that are specific to DynamoDB. We will look how exactly you are going to manipulate data in DynamoDB, because that is a little different from how we do it in the relational databases. And then we will talk about a very simple use case demonstrating how exactly data modeling happens in DynamoDB. So let's dive into the basics. So what exactly is DynamoDB? So DynamoDB is a key value document NoSQL database. So it's fully managed by AWS, which means there are no ops that you need to take care of. The ops refer to things like taking backup, recovery, setting up a failover, setting up a live replica. So all that stuff is taken care by DynamoDB. It is built for scale. So DynamoDB guarantees that you will get a single-digit millisecond response for the data that you store in the DynamoDB, whether it is 1 GB of data, 1 TB, or 10 TB of data. The other difference is it is accessed via HTTPS, and authentication happens via AWS IAM. In traditional relational databases, it happens through persistent TCP connections, and you require something called as a proxy, SQL proxy, to manage such kind of service, such kind of, you could say, open connections when you scale. It also falls into the category of hyper-ephemeral compute. So hyper-ephemeral compute basically means that you pay for what you use. So the services like Lambda, SQS, SNS, these fall under the same category of hyper-ephemeral compute. Let's look at some of the basic architecture of of the DynamoDB. So in DynamoDB, all the requests are routed through a component called as a router. So depending on the value that you are sending to the router, it is hashed, and depending on the hash value, it is then forwarded to one of many partitions that are present behind the scene. So router is again a piece of code or a piece of infrastructure, and partitions are the different nodes that are that run DynamoDB in the backend. So as you may have figured out, DynamoDB is a totally distributed database. So all the distributed, you could say, systems are governed by something called as CAP theorem. So in what exactly CAP theorem says is, so there are three vertices of this particular CAP theorem. One is consistency, the second is availability, and the third is partition tolerance. So CAP theorem says that for any distributed system, you can only have two of these vertices satisfied, and you will always end up compromising on the third one. We will talk about the implication of CAP theory in DynamoDB in a minute. So whenever you write data to DynamoDB, it is replicated across at least 3 partitions. So there is always a high availability, and a failover is always present in case a piece of infrastructure goes down. So we mentioned CAP theorem. So like the CAP theorem says that you need to choose between the 3 vertices. So AWS has chosen partition tolerance and availability, which means that you will have to deal with eventual consistency if you are using DynamoDB. So what exactly does eventual consistency mean? So let's take a look at this diagram. So let's say you make a write, and through the router, the hash and through the hashing value, the router routes it to an appropriate node. So in the node, the data is written inside a storage pod. So the write is considered successful when there is another pod which responds back with success. So for like I mentioned in the previous slide, so there are at least 3 replication for your data, and if 2 replication happens, then the success is considered. Now let's take an example that at the time of writing this data, there is some other service who is also trying to read the data from the same, you could say, node. So there is a 33% chance that the data is being read from the third partition where the newer data has still not been written or updated. So this is what basically means as eventual consistency. But this does not mean that you will always, you could say, end up being having the eventual consistent data. But you can mention a parameter called as consistent read in your read APIs that we will look into later. And then it will, you could say, always read the data from the leader node. That actually that means it will also take some little more time than the general request. So let's look into the architecture in from a little different lens. So as you see that in 3 different availability zones, there are multiple routers that have been spaced. And whenever, let's say, you make a request, you make a read or write request, then this request is, you could say, sent to one of the random routers, and that router then determines where exactly to write the data amongst the multiple, you could say, storage nodes that are available with inside the DynamoDB. And there are other 2 replicas again, which are, you could say, kind of managed by DynamoDB itself. You don't have any control over that, and DynamoDB does it for us. Now we have looked at the architecture. Let's look at some of the terms and nomenclature of different things that are there in DynamoDB. So if you draw comparison with relational databases, a table is called as a table in DynamoDB, but a row or a tuple is addressed as item. The column is addressed as attribute, and column value is called as attribute value. So we will look at it why it is so in the next few diagrams. So this is a typical NoSQL DynamoDB table. So you see that on the left side there is something called as a primary key. So a primary key is used to identify each item inside DynamoDB. So the combination of the PK and SK must be unique, must be able to uniquely identify each item inside the table. So this whole structure of primary key and attributes is called as a table. So now let's talk about primary key. So like I mentioned, and like it is named in relational databases as well, a primary key is a key which uniquely identifies each row in relational database. In the case of DynamoDB, it identifies each tuple. Now there are 2 components that you see here. One is the PK, which is also called as the partition key. And second, there is the SK, or it is called as a sort key, or sometimes called as a range key. So the combination of partition key and sort key uniquely identifies each item in the DynamoDB table. Why is it done so? We will look at it in a later point. So, oops. So this is what is called as an item. So this each row inside the table is called as an item, and the value that are now highlighted are attribute and its corresponding values. So if you carefully observe, if you have carefully observed, you will see that each of these items have a different attribute and attribute value, you could say, data. So that it's not necessary to have the same number of columns in NoSQL or in the DynamoDB as such, so that it gives you a flexibility. So if you look at the item number 2 and item number 3, you will find that the order is different, and also the category attribute which is present in the first is not present in second, but it's present in third. And also if you look at the last item, you will see that the attributes are totally different. So this is the flexibility that you get with NoSQL database. Of course, this comes with a little bit of, you could say, trade-offs. which we will look into as we progress. So there are two types of indexes in DynamoDB. So one is local secondary index, and second is a global secondary index. Before we dive into local secondary index and global secondary index, we need to look at how partition key and how a sort key works. So a partition key is basically the key which is used by the request router, which will be hashed, and depending on the hash value, it is going to assign a node in the storage for that particular value. So every time, let's say you pass that particular partition key, the router returns back the hash of this value in O of one time, or O of one complexity. And so basically constant time complexity. And then your request is routed to that appropriate storage node. The sort key is used to uh, sort, as the name suggests, sort or order the terms within that particular partition. So if we go back to the previous, you could say, table, here you see that the partition key says order 001, but the sort key says item 156, 157, 158, and profile 10. So basically, when I write a query like I want to fetch something from this particular table where order hash is 001, so it is going to hit that particular partition where this particular data is being stored. The sort key then can be used to filter out the exact item that you want within that particular partition. So one big downside of having to work with NoSQL databases is you can only you could say filter your values on the basis of partition key and on the basis of sort key. So the primary the partition key is used to identify the particular partition, and the sort key is used to find the data within that particular partition. So you cannot do filtering on top of any other attribute at random in NoSQL databases. So let's take a look at the indexes again. So there are two types of indexes: local secondary index and global secondary index. So local secondary index basically means that you can have a different sort key for your partition key within that index. So basically, in the backend, DynamoDB will create a secondary index for you whose partition key is going to remain same as that of your base table, but the sort key will be different. So it builds up an index in parallel for you. The local secondary index uses the capacity of the base table. So whenever you are provisioning a DynamoDB table, you need to specify how many read units and how many write units that you are going to use. Of course, this has been, you could say, overcome recently by something called as on-demand mode. So if you're using on-demand mode, then that is you don't need to worry about the write capacity units and read capacity. So there is a hard limit when you're using local secondary indexes, that you can have a local secondary index of the value of maximum 10 GB per partition. So once you start hitting once you start hitting above 10 GB, you will start getting error from DynamoDB. So you need to use local secondary index very carefully. Also, the local secondary index can only be defined at the time of table creation. One good side of local secondary index is you can request consistent reads from local secondary index. So you can use the consistent read parameter and you will get the consistent reads for the data which is present in the local secondary index. A global secondary index is something which allows you to choose a different primary key and a sort key altogether for your table. So basically, it is like creating a replica of your table, but having a different partition key and a different sort key. So the capacity for the global secondary index does not depend on the base table, and you need to define it. You need to define it separately altogether. There is one big caveat that all the reads and writes to the global secondary index will be eventually consistent. So you cannot use the parameter, you could say, consistent reads to get you could say consistent data from global setting indexes. Uh, the other upside is it can be created and deleted at any time, and like I mentioned that you will only get consistent reads. So what exactly is different in DynamoDB when we compare it to relational databases? So one big difference is you don't have SQL support at all. So you need to communicate with DynamoDB using either the CLI or the API layer. There are no joins in DynamoDB. Since it is built for scale and join is an operation which takes up a lot of CPU, so they have eliminated joins altogether. It also means that you need to heavily denormalize your database when you are using DynamoDB. So there is even no ACID, you could say, support. There is a workaround available, but it cannot be called as a fully ACID compatible database, in my personal opinion. There is something called as a single table design that we are going to look into in the example. And like I mentioned, that you can do you could say filtering only on the basis of primary key and sort key, which makes it a little difficult for people coming from a relational background to work with the DynamoDB. So if we don't have SQL support, then what? So like I mentioned, there is an API which can be integrated into your application. And for administrators or casual users, you have the command line interface or CLI. The joins, since there are no joins, you have to mimic the joins by denormalizing and by defining your access patterns. We are going to talk about access patterns later. In general, you will have O of 1 and O of login type of time complexity when dealing with DynamoDB. So the O of 1 is the consistent time required by the router to route your request to the appropriate, you could say, node. And in worst case scenario, if it is hitting a secondary index, then O of login is the time complexity. Since there is no ACID, the data integrity becomes becomes the responsibility of the application, and this is something which developers are kind of used to pushing it on the database. So this is going to change with DynamoDB. You also have something called as since I said that there is only single table, then you need to fit multiple entities into a single table. So this is a big design challenge for people who are coming from relational background. And like I already mentioned, that a major filtering happens through the use of primary key and sort key. So what are the major missings as a relational developers? These are the things that I really missed when I started working with DynamoDB. So there are no joins, as we mentioned multiple times. There are also no constraints because we are not using multiple tables, so it does not make sense to have a lot of constraints other than primary key. So there is no foreign key, there is no unique constraint, not null, check, or default. There is no support for aggregation or grouping. So this again, again, DynamoDB is heavily customized or heavily developed for OLTP type of workloads. So for OLAP workloads, this is not a very good choice. Again, when we are working with relational databases, we are used to the locking being implemented from the database layer, but that is again removed. So you need to take care of locking from your application layer. And also with the use of primary key, foreign keys, and constraints, you are able to maintain the data integrity. Now, since that is also missing in DynamoDB, it becomes the responsibility of application to make sure that the data has the integrity in the database. So that being said, let's look at how exactly we are going to manipulate data in DynamoDB. So for application code, there is something called as a DynamoDB API. So you have, so I'm mentioning just a few APIs here, and we are not going to deep dive into them. So there is get item, put item, update item, date item, and the SQL equivalents of it is select, insert, update, and delete. So in get item, so you basically you fetch the item. So in get items, you say what you provide the partition key and the sort key, and the related items are written back to you. Input item, you are going to write the data inside DynamoDB, and if the data is already present for that particular partition key or the primary key, it is going to override that particular value. So there is update item, which is a little peculiar because it will create an item if it is not present, and if it is present, then it can add, remove, or alter the attribute and attribute values. And delete, you could say item does the work of the delete statement from relational database. But these API actions are basically embedded from the application code. But if you're a casual user, or if you're someone who just wants to look at the data, then you can use the CLI commands. So CLI commands can be typed from a terminal, and your user is authenticated by using IAM and using secret access key and their public access key. So the first you could say CLI action is AWS DynamoDB get item. Then you specify the item table name, and then you specify the key JSON. So what is the contents of JSON? We will dive into the next slide. Just give it a moment. So in this key JSON, we have nothing but define the primary key and a partition key and sort key. So similarly for put item, so we call the put item command. We specify the table name and then specify what kind of you could say data I want to push inside. So for a similar thing is there for update and delete item. So in update item, you see that there is an expression that you update. There you see something as hash y and is equal to colon y. Also hash at is equal to colon t. So these are you could say parameters or variables that can be replaced by using the next two commands, that is expression attribute names and expression attribute values. Another command that we have is the DynamoDB delete item, and it works quite the same of other CL actions. There are so many more CL actions, but I have just picked a few to go through in this particular slide. So let's look at, so this is the JSON. So basically it's a key.json. If you see, it says artist, then S stands for string and its the corresponding value, and then song title S, which again signifies string, and then some value. So if we go back to that particular get item, so basically what it will do is AWS DynamoDB get item will go and look at music collection, and it will look for key with whose attribute name is artist and the value is no one that you know. So that is your partition key. And within the partition key, it is looking for a song which has a title Scared of My Shadow. So similar term for item.json. So basically when you are trying to insert, so item.json was called in the put item command. So it is going to insert values for artists, no one you know, song title Call Me Today, and album title Somewhat Famous. So likewise, in update, we mentioned that hash y. So we have provided the hash y value as year in expression attribute items, and a hash at as album title, and the corresponding values of colon y and colon t in expression attribute values on the right. That is colon y is equal to number 2015, and colon t is string longer than ever. So this is a little different from SQL, and it takes a little bit of you could say getting used to, and a little bit of practice to really get used to the CLI. So we talked about DynamoDB, how it is different. Now let's take a look how we are going to model data using DynamoDB. So these are the three high-level steps that you need to follow. So, and whenever you have some requirement, you create an ER diagram for it. So this step you are anyways going to do for the relational database. We are going to follow it here as well. Once you create the ER diagram, then you need to sit down and carefully define all your access patterns, because these access patterns are going to define the way you are going to define your primary key and sort key, and your entire fetching of data from DynamoDB depends on how well you have defined the primary key and sort, the partition key and sort key, pardon me. Then we are going to implement this access pattern using the primary key and secondary indexes. So let's take an example that let's say I want to create a personal book mobile application. In that there are these particular requirements that I should be able to create an you could say account using email address. I can add a book to a to read list. I can rate book on the scale of 1 to 5 after I'm done reading. I should be able to add summary. Then when exactly I finished, I should be able to update the data, and optionally I should be able to load a picture of the book. Then from the application side, I should be able to search books which I have added. So that is very important, which I have added by title, author, and genre. And also I should be able to list the entire to read and already read books within the application. From author side, the author should be able to log in and see that how many people have their books by title in their read list or read list. So the step one, like I mentioned, we create an ERD. So this is a very simple ERD, very crude ERD that I've created for the demonstration purpose. So there are three entities. There are user, book to read, and book read. So there are a few attributes that I have identified, and primary keys have been defined. So this is the relational way of doing it. Well, like I mentioned in the steps, you will first need to create an ERD, and then you will determine how are you going to, then you will define your primary keys, sort key, and the primary key which will fit this particular patterns. So let's jump into it. So let's define the primary key and sort key. So what I've done is since if you remember, so we have talked about what DynamoDB is and how it differs from the relational database. Now let's dive deep. Dive into how we can model the data in DynamoDB. So it's a little different process. So the steps involved in modeling are: you first need to create an ER diagram as you do with your relational databases. You then need to sit here with your project manager, product manager, business analyst, and carefully write down all the access pattern. So access pattern basically means that the way data is going to be fetched to be displayed in the application, and the way you need to filter or access the data from the database. And then you implement these access patterns using primary keys and secondary indexes. So for the sake of demonstration, we are going to use a personal, you could say, book application, a mobile application, where there are simple requirements like I should be able to create an account using email address. I should be able to book that I wish to read in to-do list. I should, once I am done reading, I should be able to rate the book, write the summary, capture the date on which I have completed that particular book, and optionally load a picture of the book. I should also be able to search the books that I have added by its title, author, or genre. The user can also be able to list the entire to-do and already read books list. Okay, and there is this another persona that we have added, that the author should be able to log in and see that how many of the people are reading one of his titles. So the step one is we create an ERD. So this is a very simple and crude ERD that I've created for this demonstration purpose. So there are three entities: user, book to read, and book read. So these are the few you could say attributes that I've identified for them, and this will work for the relational database. But since the step is little different, what we are going to do is now we are going to define the access patterns for the requirement. And after analyzing the requirement, these are the you could say primary key and short key definitions that I have come up with. So the entity, I have only identified two entities: a book and a user and a book. The reason being, if you look at the previous one, the book to read entity basically when it makes an entry in books read or table, it is nothing but adding you could say a list, little more attributes to the same books that has been added in the books to read table. So Here I'm making an assumption that a user is only going to read a book once, and hence we are clubbing the two entities into a single entity. Once we club that, so these are the primary key and sort key that I have come up with. Why I have come up with, we'll get to that in a minute. So now let's say now I have for that, but for you could say both of these options for user and books, the primary key that I've come up with is username and the sort key is email and title. So now if you see on the left, the primary key is user hash Anurag Kai, and the sort key for first option is email hash something. So the first item is basically representing the user entity, and the next two items are representing the book entity. So this is the flexibility of NoSQL databases. Within the single database, I was able to club two entities, and I can have multiple, you could say, attributes as well. So if you see the book number 2, the book Alchemist, is in the status of to read, and hence it does not have the extra parameters on its side. But the book deep work I have already completed, and I have then added the extra columns like rating, summary, and image. So image is basically a S3 link that we have put in there. So with this particular, you could say, with this particular setup of primary key or the partition key and the sort key, we have covered the requirements number 1, 2, 3, 4, and 6. So for the rest of the requirements, let's see what we are doing. So for requirement number 5, it says that I should be able to, so let's go back to the requirement number 5. So requirement number 5 says that I should be able to search books by title, by user by title, author, and genre. So if you see this particular, you could say table 1, the book is present in sort key. That's why I can use it alongside my primary key for filtering. So sorting, you could say filtering by books is already achieved. Now the second thing I need to do is sort by author. So to achieve this, what I'm going to do is I'm going to define a local secondary index, and in that local secondary index, I am replacing my sort key with author name instead of the book name. So now you see I have exchanged the book and you could say author columns or attributes as such. So with this particular implementation of LSI, I am now able to look for the particular user. So in this case, Anurag Kai, I am able to use with the previous table, I am able to look at the different books that he has read. And with this implementation, I can check and filter by the authors of the books that he has read. So now there is another requirement at last which says that the author should be able to you could say check which users are reading his book. So now I have created a secondary index or a GSI in which the primary key I have taken as username, and username I have said like author hash. So the reason you might be thinking why I have done user hash or author hash, or you could say email hash, book hash. So the reason is because I have defined PK and SK as generic terms so that I can add different primary keys and sort keys irrespective of their name, irrespective of their entities. So if I had named the primary key as, let's say, user ID and the sort key as let's say author ID, then I could not have used that particular definition, or it would confuse me in the future if instead of user ID I put in author ID or such. So this is the reason of using you could say user author hash and user hash. So with the implementation of GSI, what happens here, you see that the author hash is Paulo Coelho, and then he is able to, the secondary index is, we have indexed the user hash, and in user hash we have noted down all the, you could say, details, sorry, in the sort key, when we put the user, all the data of the respective user is populated on the right. So this way we were able to, you could say, complete all the basic requirements, and also we were able to create that access patterns using primary key, LSI, and GSI. So in reality, this might not be that easy, but for the sake of demonstration and for the sake of getting started, I've chosen a very small, you could say, example. So if you have observed in point number 5, there was also another requirement that I should be able to filter by genre. So I haven't implemented that, and I'm going to leave it to you as an exercise so that you don't, you could say, forget and just leave this session and don't look at the DynamoDB immediately. Okay, that's it from my end. Thank you for watching. I hope to connect with you later on Twitter. Thank you, everyone. Bye.